Hi, I'm Luis, and in this video I'm gonna show you the functionality for the solution of the traffic project from the Introduction to Artificial Intelligence with Python. So the assignment was to write an AI to identify which traffic sign appears in a photograph with an accuracy of 97%. So we have the specifications. Basically, we have to implement two functions, the load data and the get model. For the load data, we basically just need a couple of for cycles and use the OpenCV library with the imread and resize functions. And for the get model, we just need to use the sequential and the compile. In the sequentials, well, we can start playing with some convolutional layers, max pooling, dense, and some dropouts. And also, for this case, we used a categorical cross entropy in the model compile. Now let's go into the exploration. Firstly, the objective was to replicate the neural network structure explained during the lecture, which sadly ended with a very poor accuracy of only just 5% and a loss of 35%. Then I started the exploration by adding a second convolutional layer right after the input one, but this time with the double of filters, this time 64, and a smaller kernel, only 2 by 2. The accuracy increased just a little bit, still about 5%. Then with the same number of filters, but by changing the kernel size to 4 by 4, the performance improved considerably, just up to 97%, but with a super high loss of 11. However, the compilation time also was super high, like about 30 seconds per epoch. And well, let's consider that I'm not using the GPU processing. Then we, following the same architecture but decreasing the number of filters, it turned to decrease the compilation time as well, more or less 20 seconds per epoch, and also pretty close results, so still 97%. Going back to 64 filters plus the kernel of 4 by 4 in the second convolutional layer, and adding a max pool of size 2 by 2 in between the input and the convolutional layer, the compilation time decreased a lot, like 9 seconds per epoch, but still an accuracy of 95%. Now, by increasing the pool size of the first max pool to 4 by 4, the compilation time decreased even more, like 4 seconds per epoch. However, the performance wasn't that well, just 82% of accuracy. And then, with 3 convolutional layers in a row, counting the input one, then one max pool with size of 2 by 2, the compilation time was 33 seconds per epoch, and the accuracy was relatively high, 98%. After that, one hidden layer with 60 units was added just before the output layer, also with a dropout of 0.5. The compilation time was also high, about 34 seconds per epoch, and with an accuracy of 97%. And then the final structure was the one that has been compiling all the time in background, starting with 3 convolutional layers, all of them with 32 filters, and the first 2 of them with a kernel 3 by 3, the last one with a kernel 4 by 4. Then one max pool of size 2 by 2, followed by flatten and 2 hidden layers with 128 and 64 units. Lastly, a dropout of 0.5 and the output layer. So it ended up with 97% of accuracy, which is relatively good and more or less what was expected. So that was all. Thank you very much.